Alright, today we are learning about the VESPR models. So there are five VESPR, not sure if I said it right, models. Alright. I'm just gonna give like each one of them with each molecule of them, and then their degrees and lone pairs, etc. Right. Now let's see. If we write, let's say we wrote, wait a minute. So let's say we want a linear. All right. What could be a linear? We could say it's a CO2. All right. Well, why it is a CO2? Well, think about it. If we put CO2, that means carbon is the one going to be in here, and basically we put double bond, which then we put oxygen, and that's basically symmetrical, like the lone pairs is symmetric, so the lone pairs of oxygen is symmetric, so it's gonna cancel out. So this is a good linear part, so it's a good shape of a linear, whereas H2O is not a linear. All right, why H2O is not a first, wait a minute, first, why we say it's a linear. All right. Another thing is, like, not only it's symmetrical, it's also symmetrical. That means it's gonna cancel out. All right. It's also 180 degrees. All right. So that's why it's linear. Why H2O is not a linear? So if we draw H2O, why it's not a linear? First thing, if we draw H2O, that means we put an oxygen around here, and then hydrogen, 1, 2, all right, 1, 2. Well, the lone pairs is not it's asymmetric, so it's not gonna cancel out. The lone pairs is asymmetric, so it's not gonna cancel out, and it's basically a vent shape, and that one is basically trigonal pyramidal. Trigonal pyramidal, that means 109.5 degrees in between each angle. All right. Second shape that we're talking about is basically trigonal planar. Trigonal planar. And what is a trigonal planar? One shape is it could be trigonal planar, could be boron trifluoride. So it's a BF. Wait a minute. 3, and why we say it's a BF3 will be is it basically contains 3 valence electrons, or it could be just say 3 valence electrons. Anyway, and F3, that means contain 3 bonds. So why we say boron trifluoride is trigonal planar. Well, trigonal planar is basically when it contains 3 bond angles. All right, with no external lone pairs. If we put a boron right here, all right, and we put fluoride right here, and a fluoride right here, and a fluoride right here, we can say that boron does not contain any lone pairs. All right. It doesn't matter, like this one, it doesn't matter. All right, this one, it doesn't matter, such as like carbon dioxide. Another thing is that the carbon in the middle does not contain any lone pair. So And that's why we say boron trifluoride. Not only that, wait a minute. All right. What's the degrees between them? Well, think about it. Think about the unit circle too. Does help a little, but not that much. It's 120 degrees in between each. So it's 120 degrees in between each angle. 120 degrees between fluoride and fluoride, 120 degrees between each fluoride and fluoride bond, right? So between this bond and that bond is 120. Between this bond and that bond is 120. Between this bond and that bond is 120 as well. All right. What about, yeah, here we get it. What about CH4? If we put CH4, that's a tetrahedral. So in the next shape we get is a tetrahedral. All right. And an example could be CH4, and why we say it's a tetrahedral, we'll think about it. All right. CH4 is tetrahedral because if we put here C1H, carbon, it contains 4 valence electrons, so it's contained 4 bonds, no lone pairs. H. All right. 109.5 degrees between each bond, and yeah, it's a tetrahedral because carbon does not contain any lone pairs. If it contains lone pairs, then we add another angle. All right, doesn't matter like how many. It doesn't matter. Like, just restate back to the one before. So restate back to CO2 does not matter how many, if it's asymmetric or not asymmetric. So if you put this one oxygen doesn't matter if this one asymmetric or not asymmetric. The only thing matters is that if carbon, the one in the middle, contains any lone pairs, which in this case does not contain any lone pair. No lone pair. All right. Hope that helps. What about trigonal bipyramidal, which is the 4th shape, such as PF5 is a trigonal. Wait a minute. Bipyramidal. Well, why we say PF5? Because we know that P contains 5 valence electrons. That means it contains 5 bonds. All right. No lone pairs. And what's the degrees between them? It's a 90 degree between them. So we put P right here, and we put F, and for example, we put right here F, 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2. I cannot see in here. Trying to put. Okay, anyway, just right here there's 7. 7 electrons total, including the bond. All right. 1 2 1 2 1 2. All right. Degree between each is a 90 degree. All right. That's why it does not contain no lone pairs. All right. No lone pairs, this means dipolar. We're gonna go into that fact later on, not now. All right. So just know these for now, VESPR models. What about the last shape we're talking about, or the 5th shape, is basically octahedral, such as SF6. Sulfur contains 6 valence electrons. All right. So it contains 6 valence electrons. If you write it, say this one. It's so degrees is a 90 degree each, and basically there is no lone pairs for sulfur. That means it is no lone pair for sulfur. That means